Okay, so what do we remember about these triangles? Pythagorean theorems use right triangles, so they have to have that 90-degree angle on them. And if they give us two sides of that triangle, it's going to let us be able to use this Pythagorean theorem to find that missing side. So 3 and 4 is given to us, and we want to go find that missing side of the right triangle. I need you to just remember the basics here. This only works for right triangles, and you have to have the two sides given to be able to find the third side, the missing side of the triangle. We're not talking about angles, we're talking about the measured length of each side. So this could be like 3 inches and 4 inches, or it could be 3 meters and 4 meters, okay? We're not talking about angles, it's talking about measuring the side lengths. Now, the other thing is that you have to remember the hypotenuse. The hypotenuse in this case is the missing side. It's the side opposite from your right angle of your triangle. That's going to be bigger than your legs. So my biggest leg is 4, so that means that this hypotenuse, this missing side right here, it has to be bigger than 4. Okay? Hypotenuse is always going to be bigger than your largest leg. So don't ever try to tell me an hypotenuse is smaller than one of the legs. Don't ever do that. Now, the Pythagorean theorem, we didn't talk about it a lot yesterday, but it's this awesome relationship that is true with every single right triangle. In other words, if the triangle has this right angle in it, this relationship is true. If you square the first two legs, you know, the 3 and the 4, and you add them up, it'll equal the hypotenuse squared. And A and B represent the legs, and so since 3 and 4 are legs, we'll put them in for A and B, and the hypotenuse, in this case, it's this missing side right here. That'll be the C. Um, A, let's just make that the 3 right there, so that would become 3 squared. B, let's make that the other leg, that'd be 4 squared. And yesterday we talked about we don't really care whether this is A or this is B. It's just you choose one and you make the other one the one you haven't used yet. The legs are always A and B. We don't care which order. But the hypotenuse must be C. So that's what we want to go find. And at this point, on some of these, you can literally do it without using a calculator for the first part. You would say, hey, what's 3 squared? It's 9. What's 4 squared? 16. And we don't know what C is, so that just comes down. And you can do the next part also. Hey, what's 9 plus 16? 25. So we're left with 25 equals C squared, but the C is not by itself. In fact, it's what times itself is 25. That's what it's asking you. And in some cases, you can kind of go back and figure that out yourself, like this one. But in the next example, that's not going to work. So I want to show you how we can use the calculator to do all that heavy lifting for us. See that little second power there that's on the C? We really want that to go away, so we're left with just the C. So what I do is I tell students, hey, take that second power off and don't just put it on the 25. We're going to turn it into a special sign on the other side. When you see a second power on one side of an equal sign, you can flip it over to the other side and put a square root sign on the other side of the equal sign. So literally this 2 came off and it became the square root sign on the left side of the equation. And then it equals C. So then you could pull out your calculator if you needed to and say, hey, what's the square root of 25? Of course, you and I both know it's 5. So C is equal to 5. So this length right here, the hypotenuse, is 5. And the cool thing is that, yes, the hypotenuse is bigger than either leg. Okay? And if you wanted to test that out, you could plug all the values back into the Pythagorean theorem, a squared plus b squared equals c squared. And you'll see that it really does make both sides equal to 25. So that's the very reason of what we've tried to do with some of our reasoning this year in 8th grade is to be able to take any type of equation and know that these two sides are equal to each other. And if we can plug in some missing values, we can then go and solve for the one lone remaining variable. And that's the key to using the Pythagorean theorem. Okay, let's take a look at a little bit more complicated one. Not by much, though. It's going to be about the same thing. And for this one in just a bit, I'm going to switch over and do handwritten stuff so the pacing will be more like what I would be doing in real life in front of you. We know that this is a hypotenuse side. And so it's got to be bigger than the two legs, 7.6 or 3.8. So we know it's got to be bigger than 7.6. Looking at our multiple choices down here, they're all bigger than 7.6. So we don't get to throw out an answer there, unfortunately. Here's our Pythagorean theorem, and now let's just plug in what we know. Okay, I know, let me get over to a pen here. I know that 3.8 could be one of the legs, so let's just make 3.8 into the a here. So it's going to be 3.8 to the second power. Plus, I know that this leg would be b. And if anybody wanted to make a 7.6 and b 3.8, that's fine. It's not going to hurt you. Okay, the legs can be either way. But this is our hypotenuse. It's the side that is opposite of the right angle, so we're going to leave that as C. And in order to show you how you can do this, I'm going to pull up desmus.com/scientific. That's a backslash right there. Scientific. And I'm going to show you that I'm going to pop all of this right into the calculator at once. Okay, all at once there. There we go. So it's going to be 3.8, and I need the square button. So see this a to the second power right there? Boom, there it is. Plus, let's see where's plus on, there it is, 7.6 squared. And there's my answer, 72.2. So now I can flip back over, and I can put in 72.2. So all of this in the blue box became 72.2. So that's what I like using these calculators, because you can do it all at once right there. Now think about what's happening over here on this side. We've got this C, which is what we want all by itself, raised to the second power. And I can't think for the life of me what number times itself is 72.2. I don't know. So what we're going to have to do is let the calculator do the work for us. And that means that I'm going to circle this exponent and show that it's going to come over here, and it's going to create a square root sign over on this side of the equation. Whatever's on the left side of this equation, it's going to get the square root sign, so that way my C is freed. Because see, now we flipped the version of this equation. Instead of saying, hey, what times itself equals 72.2, now we can ask the calculator, hey, what's the square root of 72.2, which is literally asking the calculator, hey, can you tell me what times itself is 72.2, which is what we wanted to know up here. We're now flipping it to where the calculator is going to do the work for us and answer that very question with the square root sign. So it's one of the things we have to do whenever you've got to get a variable all by itself away from this exponent. If it's to the second power, just put a square root sign over it. And yes, that does mean if I had it to the third power like this, what I would do is I would put a cube root sign over the 8. That's kind of extra for you. You don't need to know that, but that's what's happening there is, hey, what times itself 3 times is 8? Well, it'd be 2 in that case. So we don't need that. But here, now we got to go back to the calculator. Okay? So I'm going to type in 72.2, and we're playing around with it. Well, that's not going to work. For this Desmus one, hit the square root button right here. It's right underneath a squared. Hit this right here, and then you can type in what you want underneath the square root sign, and it already has the answer right here. It's 8.497, and we don't need it much longer than that. Okay. Now this would be rounded to the nearest thousandth. Which one of these matches up to it? It would be A right here, 8.5, because this 9 would round it up to an 8.5. So there you have it. You can take two legs from a given triangle, plug it into the Pythagorean theorem, work your way through it carefully. Make sure you take the second power off of it by putting a square root sign on the other side, and you'll be able to calmly find your answer. If you have any problems, please stop in for the chat today if you missed it today. See if you can get into the chat with me tomorrow, or message me on Google Classroom or email me. Good luck, guys. We'll talk to you later. Bye.